So we have another set of data. This is thin layer chromatography data. It's it's not similar to the melting point. However, we're going to do a couple of things that are similar to the melting point data that we had previously in the last video. So one of the things we needed to do is we got historical data here. So we've got data running from 2017 all the way through to 2023. We've got lab groups for each section that was running during the different years. And now here we are in this current year, and we've got our own data set now. So we've got several students. Each one of these represents a student. This is the data that they collected. And so we have approximately 15 students or 14 students here that collected data. And now we want to add this data to the historical data set. So we're going to concat this using a pandas function and get this data set together. Now this is just like what we did with the melting point data, and if you're not familiar with that, I'm just going to show you what we did. So what we did with the melting point data was we imported our pandas data, pandas as a PD. We read in our CSV files as a data frame. So this one was the historical data for melting point, and this is the new data for melting point. We want to do a similar thing here. So we're just going to replace these with the names of these files instead, and we'll be able to just start to use the rest of the information. We can still use the same thing, final, but we're instead of MP here, we're going to call this TLC, just change the variable up a bit, but we still are going to concat these two data frames that we pulled in, and we're going to display the final TLC data, and we can save it to a CSV file, sorry, and give it a different name than this, and we'll see what the output is like, and then ultimately, same thing, we're going to average some of the data out. So if we take a look here, we'll go to this data. We actually ran two plates. So we have a plate one data right here, and we have four different materials that we ran. We ran pure ASA, pure salicylic, and then we ran our crude sample. So we have crude RF1, so that's the lower spot value, and then crude RF2. So that's the data. And then we ran it again. So we did a plate two. So what we want to do is we want to average out these columns here. So we want to plate one and plate two for the ASA. We want to average that out. For the plate one for the salicylic, we want to average that with the plate of the salicylic on plate two, and so on and so forth. And we also have data here for the recrystallized. I'm going to edit this though at the time that we're going to use it because I don't think there's redundant data. So this is pure. No, we do need this data. So we're going to take this data out. I mean, sorry for the analysis part of it. And so we're going to average all this data together essentially. So plate one and plate two data, and then we're going to be able to analyze it. So we need to concat this to the historical data, then we need to average out the plate one and plate two data. And once we get that finally in a data frame, we'll be able to apply whatever controls, whatever sort of data analytics we want to do. On this data set, what we're looking for is box plots and violin plots. So it's a good visualization of what the data looks like, and it actually represents the TLC thin layer chromatography plates. So it actually is a nice representation of that. So to make life easy on ourselves, we're just going to take this file and we're going to copy it. So then we can manipulate it with all of the variables that we need. So I'm going to take this one here, right click. I'm going to copy, or is there a duplicate right there? And so we'll get it, and it now says copy on it right there. And so I'm going to take that file, it's the same one, and I'm going to rename this. And we're going to call this TLC, actually lab 4. We'll call it analysis. Let's see how that goes for now. And so we've got our new name. And so now that we've got our new name, we want to start applying the changes that we need. So we're going to copy the path here for this data set, and we'll Control C, Control V. So I've got my historical data here. I'm going to remove this section because if it's in the same notebook file here like this, a folder. We don't need to have that extension on it. In fact, I found it to be a bit problematic. I'm going to copy the path again, put that into there, Control V, get rid of this part here. And so we should be able to pull this information in now as two data frames, DF1 and DF2. And we're going to then, instead of melting point, we're going to call this TLC. And it is just going to be the final TLC data is going to be then concat on the pandas data frame DF2 and DF1. And we're going to do this. And we can save it as a CSV file, a brand new one. And we're going to call this lab 4 TLC data combined. And so if we're to run this, these two cells, we should hopefully call in the two data frames for lab 4. So these two right here, we should be able to concat them. So we'll put the bottom one here. So the TLC one lab 4 example data will go underneath the main one here, which is the historical. And then once once that's done, we're gonna display it, see what it looks like, and we even save a CSV file because then we can either modify the CSV file later when we're ready for it, or we can continue modifying here in the cell afterwards. So now that we're at this point here, we would like to modify the rest of the data here down as well. And so I'm gonna just change this to TLC and change this to TLC as well. And the thing that we need now is the column headers. So we don't know what the column headers are just yet. We've got a list up here, but if we want, it's easier to kind of print them out. So print your DF columns, get the actual column headers, and then we can just copy and paste these into what we want to do. So what we're looking to do, that next step that we wanted for after concatenating the data, we wanted to average them out. And so with the melting point example, we have a melting point for 1 and 2, but in this case, we're actually looking to average out the crude ASA for plate 1 and the crude ASA for plate 2, and we're give it a different name. So here I'm mixing in and modifying. The two are pretty much like TLC and melting point data, but we'll try to get this squared away. So what I'd like to do then, I'm going to hashtag this out. I'm just going to put 3 quotations here, and I'll remove these ones like that. And so what I did was I got rid of these right now, so they're not active, and so I should be able to run this cell, this cell, this cell's here, and eventually print out the columns. And if I did everything right, I should get a list of stuff, but no averages, no new columns associated with it yet. So once I get my list of actual columns. So let's try that out and see what happens if I did any mistakes. No mistakes so far. And so here's our concatenated data. So we've got up to 2004. This is all in one data frame now. Now you can pull in these data as is right now and actually do the statistics on each of these if you wanted to. You could compare these two variables through statistical analysis. I do like putting them in the same column personally, just because it's nice and neat. And then I can actually compare then, say, lab day for all the different lab days. There's a couple of iterations even with the t-test that we can do and actually have each lab day compared to a known value. So there's some benefit to having everything in the same table, although you don't have to. And let's see here. So we did get our list then. So it looks like I printed it twice. Print the final TLC data columns and print DF columns here. I got both of them and they're essentially the same. So now we got our list of columns, and what I want to do is I want to copy plate 1 and plate 2. So I want to take this average and I'll call it, say, ASA. Just leave it at that for now. And we're going to get our plate 1 ASA. I'll do Control C and then Control V here, like that. And so now for the average of the ASA spot, I'm taking plate 1 and I need plate 2 as well. So plate 2, RFASA, Control C. Now watch this. I do have a space there. So let's see what happens when we're going through doing this. If there's some sort of error comes up. I know that when there's a leading error here in the leading space here that can lead to an error. So if we find that there's an error, what I might end up having to do is actually take the whole thing like this, including the space, and put it in there just in case. Actually, you know what? Why don't I just put the whole space in? So we'll go Control C and we'll do Control V with everything. And so the space is still in there and hopefully it won't affect it. And so what we'll do is we will just check and see if this actually works on this one. So I've got all the rest of these hidden, and so now we're going to create a new column that is an average of the two. And so we've got printed out here 257 rows, 18 columns. So we should see a new column show up here, and we should get 19 columns if we were to run all this again. Let's hopefully I did it right. And so there's 18 columns in the original one, and so when we come down here, I have an error. So plate 1 RFSA, not an index. Okay, so I've done something with the uh, error here, plate AFA. Again, there's a space. See that? Let's see what happens when I just copy this. So we got to watch this. And by we, I mean me. So this originated from an Excel data file that I actually converted into CSV. And look at that, just that space. Wow. Anyway, so make sure when you do the tables in Excel or whatever you're going to use, that this space matters. And I just showed that there. Okay, so over to print the DF columns, print final columns, DF columns. So I printed them out, but I don't know how many new ones I've got. Uh, so we'll do final. Let me copy and paste this one. So I want to print out the final columns, the ones that we just edited. So I'll see what happens here. Whew. And hopefully right there, there's a new one right there, average ASA. So these are all the columns that we've done. I've printed the final TLC after we've done this work on it. So there's this one here where we just transferred the final data variable here and called it DF. I did that in a previous video because it was just easier and we're lazy. By we, I mean me. And so it was easier just to do that. If we wanted to go through and be very Pythonic, we would take this variable here and use that in place of df. But there's several of these that I got to go through, and df was much easier to use. And because I had it previously done already with the melting point, it was just easy to copy and paste everything over. All right, so we see then that after this addition here, right there, that when we print out the new data frame again, that there it is. So we've got the new column. And if we keep doing this, so I can just Control C, create a space here, Control V, and I can change these up now. So I want the average for salicylic, like this. And so now I want the plate RF1 of SA. I don't see any spaces here, so hopefully we're okay. And I'm going to put that in there, like that. And then I need my plate 2 right here, like this. Control C, put this one into place. No space there. And again, if I were to run this, hopefully we'll see then we've got the 2 column averages now being added in. And this is the data that we're going to actually do our work on itself. So you need to finish up the rest of these. I'll kind of through the magic of video, I'll go and finish these up and then we'll be able to start working on the data set. Okay, and now we've got everything here. So we're creating 1, 2, 3, 4, 5, 6 new columns. The first one is for ASA, which we're expecting only one spot to come out of it. And we're averaging the 2 plates, so plate 1 and plate 2 for the RF value. So that's the distance that it goes up the spot essentially, divided by the solvent front. For salicylic, also expecting only one spot. With the crude, we're expecting 2 spots, so we've got some starting material and some final product in it. So we're expecting 2 spots, but still, so we've got an RF1, so that's our lower spot. So plate 1, the bottom spot, plate 2, the bottom spot, we're going to average that. And so that's our crude bottom spot. And then up here we've got the crude, the top spot, RF2. So for plate 1, the top spot, for plate 2, the top spot. And we do the same thing for the recrystallized. So when I ran this through, everything worked, but there is a future warning that came up here. Essentially, I'm not exactly sure. Dropping of Nusis columns and data frame reductions is deprecated. So essentially, maybe what I'm doing here is not valid anymore, but it didn't give me the error when I was doing a few of these. Maybe it thinks some of these are the same, potentially, which they're not. So I'm not exactly sure. And so if we take a look then after we've run it, we've got our new columns. So we have average ASA, average SA, crude RF1, crude RF2, recrystallized RF1, and recrystallized RF2. So now with this data set, we're able to move on and do whatever analysis that we would like to do.